Considerable interest and controversy have been raised in astronomical circles recently over the prediction of a new, major planet in our solar system. Historically, ancient astronomers were familiar with the brightest planets, Mercury, Venus, Mars, Jupiter and Saturn, simply because they were bright enough to be seen without a telescope. It was only by accident that Sir William Herschel telescopically discovered Uranus March 13, 1781, while routinely surveying the stars in the constellation Gemini. After Uranus, other methods were needed to discover additional planets in our solar system, if more existed. The eighth planet from the Sun, Neptune, was the first to be discovered using modern predictive methods. If no other planets existed beyond the orbit of Uranus, this seventh planet should have followed the path calculated by astronomers. Since Uranus did not adhere to its calculated orbit, it was reasoned that if planet X must exist beyond the orbit of Uranus, and have enough gravitational influence to cause irregularities in Uranus's orbit. Studying the irregularities in Uranus's orbital motion, John C. Adams, a young Englishman, was able to predict the position of planet X. A Frenchman, Leverrier, also determined Neptune's position mathematically. September 23, 1846, the first planet X, Neptune, was observed at Berlin Observatory less than 1 degree away from its expected position. When Neptune's gravitational pull on Uranus was taken into account, the errors in Uranus's orbit were reduced to 1/60th of what they had been. However, the remaining discrepancies were large enough to launch Percival Lowell on his famous search for a new planet X in 1906. Although Lowell died in 1916, the search he instigated went on until February 1930, when Clyde Tombaugh discovered the new planet photographically. Since its discovery, some astronomers have argued that Pluto is not massive enough to cause the orbital irregularities of Uranus that were used by Lowell. Because of this, the discovery of Pluto may well be the most fantastic coincidence in the history of science. Not all planet X's were real. Mercury is the smallest planet in the solar system and the closest to the Sun. Its orbit is slowly changing in a way which can't be explained by classical Newtonian gravitational theory, and some astronomers believed that a planet closer to the Sun than Mercury might exist. So sure were they, that they prematurely named the hypothetical planet Vulcan. While this elusive planet was supposed to cause the slow change in Mercury's orbit, Vulcan was never found. Much later, the strange motions of Mercury's orbit were explained by Einstein's general theory of relativity. Using a computer recently to study disturbances in the motion of Halley's Comet since 295 AD, Joseph Brady of the University of California Lawrence Livermore Laboratory predicted that another planet X should exist beyond the orbit of Pluto. This hypothetical planet would be twice as far from the Sun as Neptune and have 3 times the mass of Saturn or nearly 300 times the mass of Earth. In fact, it would be more massive than all the other planets except Jupiter. Brady employed the same method used to find Neptune and Pluto. However, instead of looking for irregularities in the orbit of Uranus, he looked for these irregularities in the orbit of Halley's Comet. This comet regularly returns every 76 years and has been observed since at least 87 BC. By carefully choosing just the right mass, position and motion for his new planet X, Brady found he could reduce the difference between the comet's calculated and observed orbits by 93%. If this new planet X exists, it will be the strangest planet in the solar system. For example, all the known planets travel in orbits confined to the same approximate plane, called the plane of the ecliptic. In other words, if we represented the Sun and the planets on a flat tabletop, one would be very far above or below the table's surface. Pluto is the only oddball exception. Its orbit is inclined a whopping 17 degrees from the plane of the ecliptic. Planet X would have an even greater inclination, c 60 degrees, which would place it far north of the ecliptic at this time. Moving outward from the Sun, the planets become larger and larger until Jupiter, the largest. Then they start getting smaller again. Planet X, far beyond Pluto, would probably be the second largest planet in the solar system, which does not fit the apparent pattern. In addition, All the planets are moving around the Sun in the same direction. Most astronomers believe this tells us something about the way the solar system was formed, especially since the Sun rotates in the same direction. But Planet X would be moving around the Sun in the opposite direction. It would be difficult to fit this retrograde motion into current theories on the formation of the solar system. The critics of Brady's Planet X point out that a planet as massive as he suggested, and positioned so far above the ecliptic plane, would strongly disrupt the orbits of the outer planets. The gravitational attraction from this giant Planet X would pull the planets Jupiter, Saturn, Uranus, Neptune and Pluto out of their present orbits. Since the planets are not being pulled out of their ordinary orbits and in view of what is known about the physics of the solar system, critics point out that such a planet is highly unlikely. Still, the possibility of discovering a new planet is very exciting to most astronomers. Because of this, photographic searches have been made covering a substantial area around its predicted position, but nothing has been found. It took 24 years to find Pluto, and astronomers are not yet willing to completely rule out the existence of Planet X. However, the observational evidence against Planet X seems fairly strong. If Planet X doesn't exist, astronomers ask, what makes Halley's Comet act so strangely? Comets can best be described as dirty icebergs. The molecules in the ice are probably methane, ammonia and water. As the comet approaches the Sun, the ice starts to sublimate, change directly from an icy state to a gaseous state, and molecules and parts of molecules fly off into space. Excited by the Sun's radiation, this gas glows and forms the familiar tail, which may be as long as 100 million miles. Sometimes this sublimation may occur quite rapidly from only parts of the comet, acting like a weak jet and changing the comet's orbit slightly, an effect observed in some shorter period comets. Brady's critics point out that if you scale up non-gravitational effects observed in the lesser comets, you would have about the right effect on the orbit of Halley's Comet. It seems now that most of the evidence is against the existence of a new Planet X. All the arguments of the critics will crumble to dust, of course, if someone finds it. If it isn't found, it probably means that there are no undiscovered major planets in the solar system.